Hi everyone, this is Lenny, your host for Systems at Scale Fall Edition. Thank you for attending the Fall Edition of Systems at Scale. I hope you enjoyed the last 3 weeks of talks. I know that I left the last 3 weeks quite inspired, and definitely hope that you stick around for the upcoming live Q&A hosted by Ayichew. And here he is right now, and I will pop away and you can ask the speakers questions.
Thanks, Lenny. Hi, I'm Ayichew, and I'm an engineering manager at Facebook Infra. I'll be your host for the Q&A panel. I'd like to welcome the speakers back, Jos, Jasmit, Dillon, Jeff, and Tyler, to answer some of your questions. So I'm going to try and be as equitable as possible based on the list of questions that we have. So I'll try and do a round robin and call on you to kind of take on some of the questions. With that, the first question is going to go for Jos. So,
yeah, can you hear me?
Yes, I can. So the first question for you is, apart from configuring Kafka correctly, are there other considerations for users that could actually influence performance?
Yeah, I mean, like a lot of it is still beholden to the software that you write. One of the most important things is the design of the key space. The Kafka broker splits your topic into partitions, and the key is used to decide which partition a particular record goes through. So in order to get like good balancing of the writes across all the partitions, you need to have a key that allows, after hashing or maybe after writing your own sort of like partition chooser, but that hits every partition at an equal probability. One of the problems we often see is if there's a bad key design or a bad hashing design, then one partition is hot because most of the writes go there, and the other partitions are too quiet. So that's definitely a big thing that you can control yourself. You should also keep up with Kafka versions generally. Like there's a lot of effort being done in the open source community to make Kafka better and faster, and so keeping up with Kafka versions is in itself is an important performance strategy.
Oh, great. Thanks for that quick response. For this one is for Dillon and Jasmit. So there's a question around the replication policy on MySQL Shard Manager. The question is around, are you using a Razor coding algorithm such as Reed-Solomon to determine the replica factor?
Sure, yeah, I can go ahead and take that. So short answer, no. So basically, MySQL uses a full copy of data at an instance level as a way to ensure service availability for us. The underlying physical file has a page-level checksum to avoid data corruption, but we don't use erasure coding such as Reed-Solomon. And our MySQL application topology is one primary and two secondaries, as we mentioned in the talk, which are full replicas. Lastly, we use 3 replicas to ensure that 1 extra copy is available in the event that we do lose one region to a disaster.
Oh, great. Next question is for Tyler. I think there's a question around like the trade-offs you have to do every day when you're designing the system.
Yeah, that's a great question. So one of the big trade-offs that we see is making sure that our system works well for the everyday average user at Facebook, which typically owns small stateless thrift servers that aren't replicated across many machines, versus making our system work well with other teams at Facebook that are high criticality, have thousands of hosts that they're replicating on, and need extreme amounts of flexibility and customization in their deployment pipelines. And the way that we do this is by providing relatively sane defaults for certain things like push plan configurations, so that the average user won't really have to worry about that. But for, again, these teams like Facebook's content distribution network, they're able to be extremely flexible in how they're doing that. Another good example is health checks. We provide same defaults for what conditions a service should be considered healthy. And again, the average user probably doesn't really want to worry about that. But there's limitless flexibility for services who do want to add more customizations. They want to check things like memory, CPU, number of crashes, business-specific metrics, and so forth. And so we let them do that.
Great. So moving along, the next question is for Jeff. I want to see what your thoughts are on decomposing. People are interested in what is the strategy for decomposing monolithic services into microservices.
Yeah, I mean, that's a pretty good question. And we have to do this a lot at Databricks because we obviously started off as a small startup where we had it was much easier to build monoliths in the beginning. We kind of had two complementary approaches. So one was sort of decomposed by functionality. So for example, if we had this big web application that had many different features in it, like one was serving SQL, one was serving like interactive notebooks and stuff like that. So it's fairly straightforward to say like, oh, these features are like unrelated, we can decompose them. The second approach was to decompose by looking for bottlenecks in the system. So like basically, for example, we had like a cluster management system, which was basically a sort of a work queue, but it was like implemented within a monolith. And it was fairly straightforward to see that there was a bottleneck in the sort of distribution of work. So we sort of decomposed that into sort of a master with some workers. In both cases, like we took a pretty strong like data-driven approach to decide like what to decompose because, for example, like in the web application approach where we decompose various functions, we looked at like what was the highest load API and like tried to pull that out of the monolith. And then in the sort of cluster manager decomposition of a bottlenecks approach, we basically like did a lot of instrumentation and analysis to figure out what the bottlenecks were, and then using that data to drive like what decompositions to prioritize first. Because refactoring and migration always take a long time, and it's like fairly dangerous if you like do it in a way that's not careful. And so this data-driven approach is like pretty useful for us to maximize the ROI in terms of deciding how we would go about decomposing and what features we would actually break apart first.
Great, thank you. Coming back to Jos again, this is a question from viewers that is asking, what are the challenges you face in isolating customers in multi-tenant Kafka, and how do you handle them?
Okay, yeah, so we have different levels of multi-tenancy, and so the answer is a bit split depending on what kind of cluster you create. The big split is between what we call the dedicated clusters and the multi-tenant clusters. If you create a dedicated cluster, then we host your brokers in their own containers and depending on the level in their own virtual machines. And so that means that your data will go to a set of brokers that don't handle any data from other customers. And so the isolation there is provided by the container technology, typically Docker on the cloud, and the virtual machines. And that, of course, provides like a very high level of isolation between different customers. We also have a slightly more cost-effective option where we mix and match logical clusters, as we call them, on a set of brokers. Kafka itself organizes its data by topic. So every stream is a topic, and Kafka, just out of the box, the open source version, already does a really good job making sure that data that goes to a topic stays in the topic and it doesn't leak out of the topic. And so that in itself provides a reasonable guarantee. We now have to make sure that you don't access topics that you're not allowed to sort of access as a customer, and we have a security layer in Kafka that can implement that. So if you connect, you pass your API key, your username and password basically, and that only gives you access to the topics that you created, and then Kafka does a job inside of itself to make sure that you don't access any other data. However, because in that case, data from different customers is managed by the same set of brokers, there are, I won't say problems, but there's challenges with performance and load balancing. These clusters that are on the multi-tenant infrastructure have usage limits, and these usage limits are like how many megabytes per second you can stream in and out, and how many partitions you can have, and how much storage, how long you can provision that, and there's a bunch of things like that. And knowing all of these upfront, these limits allow us to size the cluster well, to have enough brokers on enough machines with the right amounts of memory and CPU to make sure that sort of the set of brokers as a whole can manage the set of clusters as a whole that we're provisioning for the customers. And once that is a basic match, then it comes down to load balancing that all the customers' data across all the brokers. And then again, Kafka does a pretty good job sort of replicating partitions to brokers and moving these partitions around. And then we have a rate limiter to make sure that you don't go over these limits. So it's a combination of isolation provided by the cloud technology, virtual machines and containers, isolation provided within Kafka, and load balancing by Kafka. But like everything, the devil is obviously in the details. But these are sort of like the three levels where we implement things and can provide isolation.
Great. Thank you. So, kind of continuing on going around, like the next question is for Jasmit and Dillon. How does the disaster recovery approach of Fox compare to the industry parallels in queuing space, such as Amazon SQS?
Yeah, I think I can take that one as well. Yeah, using SQS as an example here, I believe that their platform kind of ensures high availability of data by replicating across availability zones within a region. So I do think there are means of kind of replicating cross-region if you want to do so, but I think that kind of requires setting up some additional machinery to support that and isn't kind of inherently supported by SQS itself. So, I think primarily one of the big differences there is Fox offers that and manages cross-region replication for you as part of the service. So there's no additional steps or machinery required to ensure that your data is available across multiple different regions.
Thank you. Next question. I'm gonna skip and go with Tyler for this one. So the question is around conveyor. If the conveyor system is broken, are users able to still deploy code?
Yeah, that's a great question. Yes, they are. There's a few ways that we allow them to do that. The first is we have what's known as conveyor in a box, which is a command line tool that's rolled out to developers' development servers, where they can effectively run the entire conveyor environment locally, which would allow them to do a deployment if our system is completely broken. So now let's say in the absolute worst case, even that tool is broken. There are still other ways to actually deploy their code. One example of this is for the 95% of teams at Facebook that run their code in containers, Facebook's container system is called Twine, and Twine also has its own command line tooling available, which is generally extremely reliable, and even in the event of a complete conveyor breakage, should be available to service owners. So if they can't use anything like any of Conveyor's tooling, they can always manually update their service through the Twine command line tool, but only as a last resort.
Just a kind of quick follow-up, since I think it's an interesting question.
Sure.
So if this is a way of kind of bypassing and making the updates, what are the risks there, and that how does Conveyor kind of deal with that?
Yeah,
like in terms of
question.
the state difference, yeah.
Yeah, exactly. So that's I think you've done a good job of highlighting what the issue of actually going around the conveyor system and actually using these command line tools directly is. That is, it's very easy to kind of shoot yourself in the foot if you're bypassing your continuous deployment system and manually SSHing into your hosts or using a command line tool that directly interacts with the container scheduler. So the big disadvantage there is that you don't have any of the safety mechanisms of Conveyor. There's no health checks, there's no sanity checks, and it's kind of up to you to make sure that this is not going to bring down your entire service. There are certain ways that at a lower level, you can ensure that your service isn't going to, even if you're using these low-level tools, completely topple over. So in our deployment or our container configurations, you can set, for example, what's called a step size, which means the minimum number of hosts that can go down at a time. So even if you were to go and manually update all of your hosts through the command line, it wouldn't do that all at once unless you provided a specific flag. It would do it very gradually. And there's even a very primitive health check system built into our container system that will basically just make sure that hosts are responding to a simple health check request, like a heartbeat request, effectively.
Thank you. Jeff, I want to come to you in terms of I'm going to throw a couple of questions in your direction, which is, one is, I think you touched on this a little bit. What is the hardest thing to abstract away in a multi-cloud platform? And somewhat slightly different question, but I think it's interesting, is what is next for this data platform factory approach?
Yeah, sure. So I can answer each of those in turn. So there are many things that are actually difficult to abstract away. So one of the ones that was particularly difficult was identity and access management. Each cloud really does access control in a very different way. So for example, AWS uses IAM roles to control access to most of the resources. Azure uses Active Directory and has a hierarchical RBAC system. And in Databricks, we found that native access controls actually aren't that great a fit for getting access to data in the way that customers want to access it, often because they typically limit access to data at the file level. Like if you're writing like an object to S3 or ADLS in Azure, then those access controls gate access at the file level. So that's the most granular access that you can basically control. And most customers store their data in one of these blob stores like S3 or GCS or ADLS. But typically users actually want access control at a more granular level, like at a table level or a column level for their curated tables. And so if you're using a file format like Parquet, it's like you can't really partition the access that way using the cloud provider's mechanisms. So we basically built like our own uniform data access controls on top of the cloud provider ones that use sort of table level metadata that allows our customers to express access control at this level, and but they have the immediate access through our systems. And this allows them to basically have their data stored in these sort of cheap blob storage systems, but also have more granular access control. And we actually have a new project called Unity Catalog, which kind of aims to provide this level of access control and data governance across like all the data objects, both within and outside the enterprise, to allow both sort of the sharing of your data in a secure way, but also like in a controlled way, so you can basically secure access to it. So for example, like people that shouldn't see the column labeled credit card numbers can't see that column. I think the second question, maybe you can remind me what it was. I think that went a little bit long.
It was what's next for the data platform factory?
Got it. Yeah. So there's many things going on. I'd say that in terms of like building the, allowing our engineers at Databricks to build more features in their data platform more efficiently, I think one thing that we're currently working on very heavily is experimentation. And to allow more rapid release of changes. I mean, this kind of goes into sort of Tyler's presentation as well. Experimentation and A/B testing are like very commonly used in consumer software already. But enterprise using experimentation for enterprise software, like doing A/B tests and releasing software in sort of with experimentation, comparing the old version versus new version. There's unique challenges in enterprise software because number one, there's a much lower bar for like bugs and regressions. Like when we have a bug, it's not just like an ad not showing up in someone's web page. Some customers, like production workload might break. And secondly, there's like a clear differentiation in workloads. Like not all users and workloads are equal. So we can do pretty interesting things in terms of the experimentation to like sort of prioritize sort of canaries and less important workloads and gradually introduce changes and experiments that way. And this is like something that we're actively working on, and I think there's like pretty interesting work in this space.
Thanks. Next question is for Yos. If this is more like, I guess, how fast will Kafka go if it's properly tuned? This is something I think people are curious about. But somewhat related to that is I also want to see like what happens with workload changes. Like can you retune like the Kafka cluster to address that? So I'll follow up if that helps.
Yeah. No. I get the picture. So how fast will Kafka go when I tune it, and then when my workload changes, what happens?
Yep.
Yes. So we do a continuous load testing over at Confluent to keep track of this. I mean, Kafka was designed to be a bit scrappy, and there's we've done some load tests. Well, we have benchmarks that go all the way back, but we've done some load tests recently that shows that you can easily get 100 megabytes per second on 6 very cheap machines. So these are low-end machines that you can buy for like $1,000 at your local Best Buy. And as I also said in the talk, Kafka scales linearly quite well. So if you multiply that by 10, you can do 10 times as much data. I mean, it's not entirely that simple, but to a large extent it is. And that number has been fairly consistent. It gets better as we do more work in Kafka. I mean, the idea is obviously that you manage to max out the network card, right? Because at the end of the day, that is the bottleneck of the data going into the machine, and we're fairly close to that. Then when your workload changes, there are some precautions that you need to take when you create your cluster initially, and that mainly boils down to the number of partitions, because that is not easy to change. But if you start, but there's no downside really to starting with a lot of partitions. So if you start with a lot of partitions, you can just add brokers, and then the brokers will rebalance the partitions over more machines, and you can just like keep pumping the data in, add some more brokers, you can sort of keep pumping the data in until you've maxed out like every network interface in that cluster. Typically, there are a few settings that you can use in order to keep up with that workload, because like it's not just about pumping the data in, but it's also about getting the data out through your consumers. And it goes again, I explained in my talk a bit about the difference between latency and throughput. So it's a bit about what you want to optimize for. Do you want to keep amazing low latency per message, or do you want to keep aggregate throughput really high? There's like, and that comes down to like committing more frequently or less frequently, waiting for message batches to fill up or not before you send them on to the broker. How often you want an acknowledgement back from the broker. So you can keep streaming that data in, and you can make some changes on the consumer side to make sure that you can keep up with it. It also comes down to running more to more consumers, obviously. So like most systems, when you get like near that max, like weird things start to happen. It's a bit like Starship Enterprise. As soon as you get to warp 9.9, like weird stuff starts happening. People's faces malform, and like the shields lose molecular integrity, or like whatever they do down there. And Kafka is no different, but it takes a while to get there. So keep adding brokers. The moral story is, out of the box, 100 megabytes per second with like a few cheap machines is not a problem. Keep adding brokers and faster networks, and you just keep streaming that data in. When you get to the edge, the settings become really important in order to sort of like keep a constant state of data production and consumption.
Thank you. That the Star Trek reference, you could see everyone's face light up, which is pretty
Yeah.
So this question is for Jasmit. What are the durability guarantees of Fox provides in case of a loss of a region without notice? I also want to ask, I think this is somewhat related, which is in terms of how does it handle like a case of failure of multiple regions?
Sure, I can take that. So in this period of time, I'll try to provide a short answer. The durability guarantees provided by Fox are pretty much similar to the guarantees provided by MySQL, as Fox is built on top of MySQL. And Fox uses a semi-synchronous replication, MySQL replication configuration. That means binlog is replicated within the same region synchronously, and query succeeds when the binlog is replicated, and the binlog is applied asynchronously to cross-region replicas. So if the secondary replica is not entirely caught up in the event when the region is disconnected, it might happen that Fox is accessing the tail data. And the loss of multiple regions, the mechanics for handling loss of multiple region is similar to how we handle the loss of one region. That means the way MySQL fails over and is accessible to customers from the available regions. However, the guarantees around SLA might differ based on availability of buffer capacity. So in the extreme case, when all the three regions are lost, which makes up for the MySQL replication topology, then the system can be susceptible to data unavailability. And in addition to that, inability to write the data until all the three replicas recover. But we have never seen such an instance in practice yet.
Fingers crossed. I was gonna ask Tyler. This is a question for you around how does Facebook handle deployments of services that are being constantly resized?
Yeah, that's a good question. There's really two big issues that can happen when services are being elastically resized. The first is that if a service is being upsized during deployment, a naive implementation might actually not update the full service. So you might have a deployment that goes to completion, and instead of 100% of your hosts being on the new version of code, only 95 are, and that's pretty bad. The other challenge is if a downsize happens during a deployment, it means that you might actually try to update some hosts that don't exist, which might fail your deployment. And so there's really kind of two separate problems here that we address in separate ways. To handle upsizes, the main way that we do this is by ensuring at the end of a deployment that, for example, in Twine's case, our container system, we send what's called a full job update, which means that any new replicas that are coming up will also be brought onto the new version. So let's say, a push takes like 3 hours. And at the, during those 3 hours, some hosts are added. At the very end, we'll send the special full job update, which will update all of those stragglers that have been added, during the deployment. To handle downsizes, our system is constantly evaluating the size of the service. And if there is a decrease in its size, we will adjust the push plan, the deployment plan, to account for this. The problem with this is that there's still race conditions. So let's say we check how many hosts there are. We see that there's 95 hosts, and then we go to update hosts 90 through 95. In that small amount of time, it could get downsized again, actually. It could go from 95 hosts to 94 hosts to 93 hosts, at which point we're trying to update some hosts that don't exist. This is effectively unpreventable, and really the only way that you can mitigate this is by doing retries. So the way that our system handles this is we're constantly constantly checking the size of the service, and if we ever get an error, try to update some host that doesn't exist, we wait a minute and then check the size of it again and issue another update. And because services at Facebook generally don't get resized that quickly, maybe like once every 5 or 10 minutes. If we're retrying relatively quickly, then this isn't much of an issue in practice.
Jumping over to Jeff, there's a question from Blue Jeans. Kubernetes aims to be an answer to IIS abstraction and an agnostic layer, but it might be quite challenging on stateful data, a data warehouse to run. How do you keep maintaining your service framework, APIs to support new features, and keep up with the public cloud changes?
Yeah, and that's a good question. I guess there's two parts to that. I guess one is around the stateful nature of data warehouses, where there is state, sort of Kubernetes, sort of designed primarily for compute, and storing a state within Kubernetes services would be challenging. So most of the state that are for like data in our data warehouses is actually stored in external storage, like the Azure, like S3 or Azure Blob Storage, and so that's kind of sort of maintained separately from the actual Kubernetes clusters, which we primarily use just for compute. But it's definitely a challenge as cloud providers evolve new features all the time and like decide like which ones to incorporate into like our platform layer. So for example, like there's this new feature in AWS and Azure that we're currently integrating with called private link, which didn't even exist like just a couple of years ago. And Kubernetes gives us a good sort of abstract compute layer and internal cluster networking, but we still have to integrate our platform with external networks and external storage systems. And our service framework layer abstracts away such details away from services so that, let's say like most services at Databricks don't have to worry about this. But we still have to do work, at the platform layer in order to support this. So for example, with private link, we have sort of a gateway service that's shared as an ingress to our Kubernetes clusters between all the services, so that when customers want to connect to Databricks using private link from their private networks, our gateway service knows how to talk private link within the different clouds within AWS and Azure. But our individual services don't need to know about that because they just are using the network connectivity provided by that sort of private link tunnel. And we're also pretty conservative with our adoption of cloud features, since we need equivalents in the different clouds. So there might be some systems that are similar across different clouds that we might take and manage in-house, because that there's a sort of trade-off between the sort of uniformity across the different clouds versus like the management overhead of like, well, we have to manage something that normally the cloud providers would manage. So one example of that is like we currently do still use like Kinesis in AWS and Event Hubs in Azure for like streaming, but there wasn't really like a good equivalent service in Google Cloud. So we've been basically moving to like running our own Kafka system in-house. So we basically manage our own Kafka now, and that allows our services to run sort of streaming in all the clouds, streaming workloads in all the clouds, but with a uniform interface. But obviously there's some cost to this, there's an operational overhead. It's like because now we're managing the Kafka system rather than sort of the cloud providers. And yeah, so that's a sort of a trade-off that we sort of make continuously as we sort of evaluate whether to use sort of the existing commodity stuff like in the clouds and try to like cobble like a common interface on top of it, or whether we sort of just manage a common thing in-house.
Thank you. The next question is specifically about open source opportunities at Facebook. I'm going to direct this to Jasmit and Dillon and maybe Tyler. But I also want to give the opportunity for others if they want to chime in. So take it away, Dillon.
Yeah, sure. Yeah, so Fox is not currently open source, but if you are interested in checking out kind of more open source stuff that Facebook's doing and potentially getting involved, you can check out opensource.fb.com, open source, all one word. Yeah, so I mean, that's about the extent of open source from the Fox world, but I'll hand it over to Tyler to see if there's anything on the Conveyor side that differs.
Yeah, not really. Conveyor is also not open source. So again, yeah, I'd encourage people to follow that link.
All right, it seems like either Jeff or Yas, if you're anything to chime in or keep going. All right, I'll keep going, it seems. Next question is for Yas, actually. What patterns can you advise for eliminating duplicate messages?
Duplicate messages. So problem with duplicate messages usually arises around failures. Like, so you're communicating to a broker, and then there's a network failure, and then when there's a network failure, or let's put it differently, like the network connection suddenly drops, you never know what happened. Like, is the network down, or is the broker down, or both down, etc. And so if that happens when you didn't get a commit back, you never know whether the broker got the message or not. And so as a producer, you can then choose to resend the message, but if the broker already had the message, you now have a duplicate message. Or you can choose not to resend the message, and then you have a lost message. And it is actually impossible in the light of a lossy communications medium, like that can lose messages, to achieve once and exactly once semantics. And for people who don't believe me, go to Wikipedia and look for the two generals problem. And it has a Wikipedia page on like two generals on a hill that sent like runners around to attack at dawn, and it proves that it's impossible to do this. So you need some help from the software to do that. And so one of the things you can do is, if you have a single writer per partition, what you can do is the moment network connection reestablishes or the broker gets back up, whatever is the case, that single writer can read the last message that was written, see if the message that is in dispute got acted or not, and if it wasn't, then write it again, and otherwise don't write it. You can't do this with multiple writers to a single partition, because now they could both take the same action. And you can. So usually the best course of action is just to write it again, and then have a deduper on the consumer side. So for the consumers where it really matters, just read it and then see it. Did I already receive and act this and handle this message? Yes, and then just ignore it. However, in order to do that well, that means that your consumer must use asset transactions correctly to write the record that it handled that message and the business transaction that the message pertains to in a single transaction. Because otherwise you can have the same sort of race that we just discussed, but now on the consumer side. So it's possible to get this sort of exactly once handling on the consumer side a bit easier typically than on the producer side, but you still have to use transactions correctly in order to do that.
Thank you. The next question is for Tyler. This is with respect to conveyor work. What happens to
record that it handled that message and the business transaction that the message pertains to in a single transaction? Because otherwise you can have the same sort of race that we just discussed, but now on the consumer side. So I hear myself. This is amazing.
Yes, this is amazing. Delayed. This might be a Star Trek reference.
Amazing technology. Yeah, this is an example of a duplicate message. You still have to use transactions correctly this thing out twice in order to do that.
Thank you. The question for
the next question is for Tyler. This is with respect to the conveyor work. What are some records that it handles that message and the business?
Okay, now that is cleared up, I'm going to finish the question. So in terms of push failures like health check failures, what's kind of the follow-up? Is it auto rollback? If yes, is it like per phase rollback or all the way back to the beginning? And what happens after the rollback?
Yeah, that's a really good question. And I think this is one of the things that if I'd had more time to talk, I would have actually talked a little bit more in depth. So I'm really glad that someone was paying enough attention to kind of ask that question. Yeah, so it's extremely flexible is the short answer. And all of the options that were listed here are effectively supported through the conveyor system. Generally, service owners tend to fall into one of two categories. The first category is when a deployment gets stuck or fails, it should be paused and an on-call should be notified. This is more common for high criticality services. And the second group of service owners is ones where typically if a health check failure happens during deployment, it should automatically be rolled back. Maybe either using the exact same push plan in reverse or just all at once. And we actually allow users to configure that as well. And we do have ways, not on reverts, but on, say, hotfixes, to actually block a deployment until a certain revision is landed in our source control system. So let's say that, a bug is landed, a health check failure flags that, and a service owner then goes and investigates it. They see, oh, wow, there's a bug in my application. Let me go fix that. They land it. You can actually go in completely through the user interface and say, block all deployments until revision XYZ is present in my binary. Yeah, and actually, there's actually additional functionality to not only do that, but actually list a specific revision that will get grafted on top of the binary that's currently running in production. And then we'll deploy that and then automatically prevent any versions of code that would roll back before that revision was landed.
Great. Thanks for the explanation. This one is for Jeff. It's a question whether you run Kubernetes yourself or use a cloud managed version and why.
That's a pretty good question. So for the answer to that is actually both. We both run the cloud managed Kubernetes, like EKS, GCS, GKE, and AKS, but we also manage our own. So there's trade-offs to both modes. So we run our own Kubernetes clusters for our control plane services, like most of the service platform that I described in my talk. And this is because we really need the strong customization ability to integrate with underlying cloud providers to keep the platform uniform, and also to have uniform performance characteristics across the clouds for Kubernetes clusters there. In addition, we update our Kubernetes clusters in our control plane fairly frequently in order to keep up with security patches and OS upgrades. So we need full control over the upgrade process in coordination with the update process of our services. Because basically services have to migrate from nodes from the old nodes to the new nodes of the Kubernetes cluster when we do the upgrades. And we need the strong coordination so there's no downtime for our services when we do these upgrades. And we do these upgrades at least once a month, so it's pretty frequent. And that was one of the main drivers of managing your own Kubernetes. But we also use the cloud managed Kubernetes because managing your own Kubernetes, especially since we have so many clusters, it can be a bit of a pain. So we use the cloud managed Kubernetes in the environments where we have more ephemeral workloads. Like for example, in our customer networks, we launch Spark clusters in our customer networks, and those also run, or at least sometimes run in Kubernetes clusters. And so since there are hundreds or maybe actually there's probably tens of thousands of those, we don't want to be manually managing tens of thousands of Kubernetes clusters, and it's easier to allow the cloud to manage those. So that's where we use the cloud provider managed Kubernetes instead of our own. So there's sort of trade-offs to both, and we kind of ended up with some in self-managed and some in the cloud managed ones.
Thank you. So there is a question around Facebook. Facebook is, and I'm going to leave it all to all three of you to kind of chime in, whoever feels comfortable. Facebook is developing a lot of technology. Does Facebook think of a solution for the cloud as well?
I mean, one way that we're addressing this is conveyor, for example, even for the simplest user, is actually still a lot of work to set up. You have to write at least one configuration file that says what the various steps of your deployment are, when they should happen, what kind of tests you want to run. And looking forward into the future, it would be nice if we could even take away that effort from users. So there are actually a couple of projects going on at Facebook that will completely abstract away the notion of conveyor. And we can think of this kind of like serverless computing, where you write some code, you land it, and you maybe touch one or two knobs on user interface, and you don't actually care about where it's being run, how it's being deployed, and basically, yeah. So it should be extremely easy to do that. And under the hood, that's typically generating conveyors that have test nodes, stage deployment, the latest and greatest in health checks, without users having to actually worry about it.
Great.
I can add a little bit more context.
Sure. Go ahead. Thank you.
So, as Dillon and I mentioned, we are from Fox team, which belongs to an umbrella team called serverless computing. So, as Tyler also mentioned, actually there are a lot of efforts in our team as well going on to raise the abstraction and make it easier for customers to use it. I would say for cloud version of it, maybe stay tuned to Facebook engineering blog, and you'll find out.
Cool. Thank you. The next question that I have is for Jos. Now that Remote Direct Memory Access, RDMA, has emerged in the data center, do you plan to support RDMA communication support in Kafka for data warehouse deployments?
RDMA.
Yeah.
What shall I say about this? Let me start by saying that in my personal opinion, all my opinions are my own, obviously. The promise of RDMA, let's put this differently. I hear more about technology like RDMA than I see people using it. And I think a lot of people's expectations of technology like that are a bit too high. And the reason for that is that, so RDMA, for those who don't know, it's like remote direct memory access. It's sort of like a direct memory to memory copy without involving any infrastructure or without involving any of the operating system or application libraries from the memory of one computer to the memory of another computer. So that promises like an ultra fast connection between two memory buffers on different computers, and the savings there are real. I mean, you have to go over some sort of channel, so there is like a fiber channel or a network or InfiniBand of some sort. The savings are real, but they are limited, which means that they're only like in the few hundreds of microseconds if you take out the TCP overhead or the UDP overhead, whatever you want. And that these savings only matter in the most challenging of use cases. Like for a lot of use cases, 100 microseconds, 200 microseconds is just not that impactful, not even on the aggregate. That said, there are use cases where it matters, but then what makes it more problematic is that the copying part is only half of it. You need to slap some sort of protocol on top of it, because if you look at two brokers communicating for replication purposes, it's not just enough to copy the message. You also need to know that it arrived, and you need a confirmation back. So you need to slap some protocol on top of it. So then some of the advantages of RDMA already goes out of the window there. So I see use for it in very challenging and very specific use cases. I'm thinking about maybe high frequency trading or sort of extremely high end use cases. On top of that, I'm afraid I'm not at liberty to say what we do internally, what we're researching internally on that topic, but bringing Kafka forward and offering support for even the most challenging use cases is very important for us. That's all I can say for now. Stay tuned.
Thank you. I think we should probably make this our last question, but I think I noticed like there's a few kind of smarter questions around Rust. So I'm going to go ahead and call Tyler on to what was your experience? What were the main kind of challenges in addition to porting libraries? And maybe you can give your opinion on that.
Yeah, that's a great question. Rust is a wonderful language. It is, the way that I see it, it fixes a lot of the issues that we've seen with Python and C++ in our code base. But there are some challenges to using it. Probably the biggest challenge is that it's just a newer language, so there's not as much community support at Facebook. There is, a lot of libraries at Facebook aren't supported in Rust yet. There's lots of little things like, as someone with a Python and Java background, it's kind of hard to transition towards doing things the right way in Rust. And the problem is, Facebook doesn't have as many people around that are Rust experts that can necessarily step in and say the correct way to do those things. That's very rapidly changing as Rust gains a lot of traction at Facebook. But there's still a lot of, nitty-gritty things that, will affect us from day to day. One example is there are still compiler bugs in Rust. It happens occasionally, not all the time, but working in a more mature language like C++ and Python, it's pretty rare that you'll see that happen. Another example is even if the same library exists in Python, C++, and Rust, it might not work the exact same way in all three of those languages. A really good example of this is regular expressions. We use regular expressions in a lot of our user-facing configuration, and a little known fact is that Python has its own understanding of regular expressions and Rust has its own understanding of regular expressions, and those are not necessarily compatible. So if we take a user configuration file that uses regexes, and that's being processed in Python, and we completely re-implement the exact same code in Rust, it actually won't work the exact same way. And we totally did not know about this at first, which led to some pretty interesting bugs. But yeah, overall, I think once our team reached a critical mass of understanding for Rust, our developer, basically, I think our developer time is much better spent. Rust does take a long time to compile, which is a bit of a downside. But overall, the strictness in typing and the strictness in things like memory leaks more than accounts for that kind of deep learning curve at the beginning.
Thank you. So thank you all for, thank you the speakers, thank you for everyone who's attended. This is a lot of hard work and a lot of effort that everyone has put into this, and I really am grateful, and I've learned quite a bit from the presentation as well as the discussions. So I'd like to thank you all for joining us and engaging. With that, I'll hand it over to Lenny, who's going to have like closing remarks. Thank you. Thanks, everyone.
Hey, this is Lenny, your host for the last 3 weeks of Systems at Scale. I hope that you enjoyed the talks of the last 3 weeks. If you happen to miss any of the talks, they'll be posted and available on our At Scale Facebook page. And be sure to follow the page to keep updated on any future events, including the winter edition of Systems at Scale, which will be coming in the next few months. So thank you again for attending, and look forward to having you at future events.